This is 2.5, all about scatter plots and lines of regression. We'll be able to use scatter plots and prediction equations, and we'll be able to model data using lines of regression. So there's a lot of vocab and terminology with this. So some vocab to get familiar with up at the top of your notes on page 7 if you're in my Honors Algebra 2 class. Data with two variables such as year and number of visitors are called bivariate data. So bi means two, variate means variable. So when we talk about data with two variables, it's bivariate. So bivariate data is data that we can represent with a scatter plot. So it can be graphed as ordered pairs in a coordinate plane. And then you'll notice as you graph, so maybe the x-axis is something related to time, so maybe hours, and then the y-axis is something related to, I don't know, like number of like bacteria grown. That's something that is common. Then you can have all these dots that come together because you can graph your hours and your number of bacteria. Those are both numbers, so you can create some ordered pairs. Correlation tells us how close or far apart these data points are, and it can be modeled by the correlation coefficient, which is represented by the letter R. So if you see that all the dots are pretty close together in a tight cloud, and if it's trending upwards, that would be called a relationship that has positive correlation. If we have a tight cloud that's sloping downward, that would be a negative correlation. And then if it doesn't really appear that there is a line at all, if it just kind of looks like a really open cloud, like a zero, there would be no correlation. Okay, so the way that I remember this, the more the points look like a zero, the closer the correlation coefficient R is to zero. And then the closer together the points are, the more that they look like kind of like a sideways one, the stronger the correlation is. And if it slopes upward, then it's a positive one. If it slopes downward, then it's closer to a negative one. Okay, so these numbers, this information down here just gives you some like numerical guidelines for a strong positive relationship, which would be positive 1/2 up to 1. Weak positive would be the points would be further apart, but they would still have some sort of upward trending relationship. And same thing with negative, except we have negative numbers. Okay, so we can find a line that approximates a set of data, and it's called a line of best fit. When you're drawing a line of best fit, if you're just sketching one, there should be roughly, if this is your line of best fit, there should be roughly the same number of points in your scatter plot above and below the line. Okay, and then this line has an equation with it, and that equation is called the prediction equation, or this is also called a line of regression or regression equation. Those are all used interchangeably. So we can use Desmos or a TI-84 to do this. Okay, I'm going to go through how to do this on Desmos in this video, and then I'll upload a separate video where we go through TI-84. I've printed out the steps for you, so if you're a Desmos person, then you're going to want to pay attention to those left steps. If you're a TI-84 person, you're going to want to pay attention to the right side. So let's look at a couple of examples. So this one, we're not going to use a calculator. We're going to try to do this by hand. Okay, so this table shows the percent of U.S. household with internet access, gives us years, and it gives us a percent. Draw a scatter plot and line of best fit. Let x be the number of years since 1995. So if x equals 0, then that's the year 1995. Meaning up in this table, 1997 is going to be x equals 2 because it's 2 years since 1995. 2000, x is going to be 5. 2001, x will be 6. 2003, x will be 8. 2007, x will be 12. That's just a common thing that people do in statistics to make the x values a little bit lower. Okay, so first thing we're going to do is label these axes. So let's let our x-axis be the number of years since 1995. Number of years since 1995. And then let's let our y-axis be percent of U.S. households. I'm going to abbreviate that as HH with internet. Okay, so graphing using this drawing tablet that I have is probably going to be a little bit rough, so we're going to do our best. I'm going to scale the axis by like 2s, so 2, 4, meaning 5 would be here, 6, and then up to 8, up to 10, up to 12. And then for the y-axis, I'll scale it like every third is a 10. 10, 20, 30, 40, 50, 60. This is not great with this type of drawing tablet. I can't be as precise with my axes. Hopefully you have a better opportunity to do that with your paper in front of you. And then you're just going to graph these points. So 2, 18 would be approximately right there. 4, 41.5, approximately right there. 5, 41.5, goodness. 5, 41.5, approximately right there. Oh, I messed it up again. Goodness. Okay. And then if we go over to 6, we are up about 50.4. 8, we are at approximately 54.7, roughly there. This is a rough sketch. And then up at 12, we are into the 60s. Okay, so when you draw this equation, you're going to want to use a straight line. And you're going to want to try to have roughly equal points above and below. So something like that would be pretty good. Something like that would be maybe not so good. If you get up into a line like this, it's not so good. So let's really try to put a line like right here. Okay, and then we're going to use this to create our equation. Okay, so this is getting into part B. So part B says to use 2 points to write a prediction equation. I see I have a point right here at 0, 10, and then I see I have another, let's see, another nice clear point right here at 220. So I'm going to use those 2 points to find the slope and intercept. Okay, so 10 is actually my y-intercept, and then my slope, if I take 20 minus 10 divided by 2 minus 0, that would give me a slope of approximately 5. So approximately 5x plus 10 would be my prediction equation. Okay. Then to use this equation to find the percent of households with internet access in 2030, I want to put in not 2030, but I want to put in 35, because remember, x represents the number of years since 1995. So 5 times 35 plus 10. Do some quick calculation to see 5 times 35 plus 10 will give us 185. So approximately 185% of households will have internet in 2030. It doesn't really make a lot of sense because it's over 100%. You can't have more than every single possible household. So that is something to keep in mind. I'm going to cut this video off here, and then I will post another one with how to do this using Desmos.